welcome to this lecture in our leadership lecture series featuring our alumni. Since there is an EML at 5 o'clock that some of you may want to go to, we will get started quickly, and I won't take too much time in introducing my speaker. I think you have all seen his bio, which was circulated. I just want to mention that he is our MTech alumnus from Electrical Engineering, 1974, and he's currently the MD of Radar Electronics Private Limited, Bangalore, and he's going to talk about innovation as a way of life. Welcome.
Thank you. Good evening to all of you. It's always a pleasure to come back to the place where I learned a lot of things and meet youngsters like you, because I'm now past 65, and so I always feel younger when I'm in the midst of young people like you. Now, I'm going to run through my presentation because I don't have too much time. If I have to finish by 4:50 or 4:55, one of the things that happens when a person crosses the age of 60 is that he or she likes to talk. And we have lots of stories to say, talk about, a lot of things that we have experienced, and so you start losing track of time. So I'll have to make sure that I don't lose track and I'm focused on the presentation that I have made. My focus today is going to be on highlighting the vast number of opportunities for you to be innovators on a day-to-day basis. I'm not going to talk about any high-flung technology or high-flung software, etc. I'm going to talk about bolts and nuts of innovation and how you can be innovative if you are in an innovative atmosphere environment, right? So that's going to be the focus. Can we have the next slide? Now this slide shows you different avatars of mine. Okay, so you see me as a Carnatic musician playing the flute. You see me as a guitar when I was in IIT Kanpur. Incidentally, I was there for a short time as a trainee as part of a public sector. You see me developing various electronic musical instruments. You see me as interested in aero models, which I used to make when I was a kid. They are static models. So I was crazy about airplanes when I was a young kid, and I wanted to be an aerospace designer, and that's how I got into Hindustan Aeronautics as a trainee, management trainee. This is, as you see, in my home workshop. That's my home, and that's my garage, fitted with all kinds of tools, hand tools as well as power tools, because I use them extensively on a day-to-day basis. You will appreciate the relevance of all these photographs as we go through my presentation, because I'm going to relate to what I experienced as a child, as I grew up, and how that prompted me to look at things in an innovative way. So my focus here is to inspire each one of you to look for this kind of an environment which encourages innovation, and as you grow, create that kind of an environment for your children, right? Because as you see there, the bottom slide, I've stripped out a cycle of my son, and the kid who was maybe at 8 or 9 years old is watching me about how the balls are placed in the hub of a cycle wheel. So education starts, even engineering education can start at that age, and that's what I'm going to highlight. Next, please. So let's talk about what is innovation, because there is a lot of confusion about what is the difference between innovation and what is an invention. Now, according to me, an invention is something that is a drastic change, drastic new technology, new process, or a new product, okay, which revolutionizes some field. Innovation is a smaller sense. It's a small twist to something you do to modify or improve a product. It could also be cross-functional in the sense it could be interdiscipline. What you see in an automobile, you implement into an aircraft, or vice versa. What you see in a tape recorder, you implement into some other electronic or hydraulic product. So innovation to that extent is a tweaking to either improve the process or generate some other benefits. So here I've got an example of a 4-colored pen, a ballpoint pen, which you all would have seen. I'm sure you will agree that it's an innovative modification of a ballpoint pen, because ballpoint pen initially had just one color, one refill. It got changed into 4. Next please. MP3 player. Now MP3 itself, what I've said here is, what is innovation? And as an answer, new product or process replacing outdated process or obsolete design. MP3 by itself was an invention. It radically changed how music or speech or any recording, audio recording was done, from a tape mechanism to a solid state, and also to compress the format. Now here it's an innovative design of an MP3 player. This is a player and it's worn like a necklace. Okay, this is a Korean product which I thought was an extremely innovative method of designing an MP3 player, which could be worn and you listen to it because you have the earphone attached right from there. This is actually the connection to the earphone also. Next please. How many of you are electronic engineers? Anybody? Okay. Now you must have heard about the 555 timer. It's a chip which is used for generating timing intervals to a reasonable accuracy, and it's in a chip form. This was developed I think 35 years ago, and to this day it is still used. It is called a timer IC 555, but this is I use this in my pump controller, pump that pumps the water from my sump to an overhead tank. It needs to sense the high level and the low level using floats. Now that means you need to have some comparator to check whether a switch is operated or a level is generated. Now the 555 IC has 2 comparators built into it as part of its function to operate as a timer. Now I used this IC because it also has an advantage that it can operate from a wide voltage of 4 volts to 18 volts. It also has 2 comparators. So using the same comparator, I have used this as a level sensor, and I thought that was an innovative way of using a FIFO, which is not supposed to be used as a comparator, is only used to be used as a timer for generating timing intervals. So this is where I say that if you have an exposure to a wider disciplines, a wider variety of disciplines, you will try to see how you can use a device that is meant for some purpose, but you use it for some other purpose effectively and very efficiently, because it's a very cheap IC. It can operate on a wide, it doesn't need a stabilized voltage. Any voltage between 4 and 18 volts it will operate, and that too it's a switching. It can directly drive a relay. To that extent it's a very powerful IC. Next please. The third answer to what is innovation: use of a new technological innovation. That is like an MP3 player itself. It resulted in a better product, higher reliability, cheaper product. Possibly when you look at the overall cost of ownership of a tape player, before digital players you had tape players. Now here you have a digital player, solid state completely, and it can store large volumes of audio. It has a higher reliability, so higher energy efficiency. I mean, these are all the qualities of a new technological innovation. It could be one or all or a combination of these. Lesser human effort in manufacturing it, eco-friendly. It could be shorter time to manufacture. It could be it could result in a lower wastage in the manufacturing process. So that's also a technological innovation. Next please. Use of modern technology. Now what we were able to do with either transistors, discrete components like resistors, capacitors, etc., and then it moved to discrete ICs where you had a comparator, operational amplifier, this, that, building blocks, to now where it is completely integrated, what you call systems on a chip. So you have a latest technology which offers the entire system on a chip. So microcontrollers is something similar to that. Then you have 3D printing. I'm sure many of you have heard about 3D printing. It's already revolutionizing the way products are manufactured. How many of you are aware of 3D printing? Do you have a system here? It's going to crazily affect manufacturing technology. In the next 3 or 4 years, it's going to revolutionize manufacturing, because you, instead of machining some things, reverse that is negative removal of material, it is going to add material and make a product through a printing process. So there are already cases of I would say metal parts of aircraft which have been printed using 3D printing, and it's already test flown and demonstrated in a fighter aircraft in the US. That's how it's going to revolutionize. Internet, of course, there was a great revolution because 30 years ago we didn't have access to information, knowledge that you people have now. Anything you want, anything, any doubt, any question, all you do is key in to Google and look at any of the results and get your information. So that's a revolutionary innovation. Carbon fiber materials. I only listed a few examples. There are many more that you can talk about, you can identify. So using any of the modern technologies, you can innovate. Instead of an aluminum, you use carbon fiber for whatever advantage. It could get any of the benefits that I listed in my previous slide. Please, next. Now, this is the core area that I'm coming to. To achieve all that, you need exposure to multiple disciplines. And that is where I feel there is a problem today in our education system. We expose a student only to electronics, only to mechanical engineering, only to hydraulics, only to chemical engineering. And you'll be surprised, during our days when I graduated as an engineer, the first 3 years were common. And I studied as much civil engineering as electrical engineering as mechanical engineering before I opted for electrical engineering. So when I built a house, I was able to draw my own plans and submit it for approval. There's a lot of mechanical design that do even today because of the grounding in mechanical engineering that I got as part of my engineering course. I think to that extent, a multidiscipline exposure will do a lot of benefit to your capability as an engineer. And this is absolutely essential. I would encourage each one of you to put your hand into as many fields as possible just to get the hang of it. Appreciation of mechanical engineering, appreciation of metallurgy, appreciation of electronics, electrical, because electrical and electronics were combined during our days. We didn't have a specialized course in electronics. But today, you have power electronics, which is considered on the electrical side, and you have pure electronics on the communication, RF, and so on. So it's good to know a little bit basics of all this as a spread, a foundation on which you can build a larger structure. So those are the things that I have highlighted here: mechanical engineering, electronics, hydraulics, software, and simulation, because that's an extremely important tool. You work with software not only to drive your hardware, but you can also use software for simulation. And what was not possible even say 20 years ago, today you can simulate almost everything that you want. Before you actually create a product, you simulate it. Hello, how are you? You simulate it, prove its functionality, and then ultimately produce it. So these are the advantages you have, and this is absolutely, according to me, these are absolutely essential for you if you really want to innovate on a day-to-day basis. As the subject I've chosen, the title of the lecture, I'm talking about innovating as a way of life, because I think it is possible to innovate on a daily basis. Whatever you do, right from morning till evening, when you handle a product, when you get into the kitchen, when you enter your bedroom, look at any of the objects, look at any of the processes, you have to ask yourself the question, is there something I can do to improve processes? Is there something I can do to change some of the items that you see or the items that you use? And I will tell you, I can guarantee that you will find solutions. You will identify a problem area or a scope, opportunity for innovation, and then you attack it, come up with your innovation. The reason I'm saying innovation has to be a way of life is that once it becomes a habit, every day you will be innovating. Whatever little you do. That's what needs to happen, and it's a mindset. Next, please. Exposure to multiple domains. So we talked about the domains in terms of engineering disciplines. Here I'm talking about domains. Telecom is a very, very wide domain. Automobiles is yet a totally different domain. Aerospace, construction, transportation. But then you can always pick out something from one domain and apply it into something else if you are exposed to it. So this the reason I'm saying this is, if I've handled an overhaul of a car engine, which I used to do. I used to rip out my car, go rip out the cylinders, rip out the crankshafts, though I was not a mechanical engineer. I used to do that because of the fact that I was born and brought up in that kind of an environment. My father was a mechanical engineer. He used to do all this at home, so automatically I picked up the trades, and as the first slide showed, my son also has picked up that trade because he is exposed to that. So if you get exposed to that, these kind of different disciplines, you automatically pick up something out of that discipline when you apply that to across disciplines, across domains. That's what I'm trying to highlight. What you did in automobiles, you might be able to do, apply in aerospace. What you learned in aerospace, you would be able to apply to automobiles. Telecom. For example, coming to communication and telecom today, you are able to communicate across the globe. You are able to activate your devices using a mobile phone, home automation. Automobiles, you have what is known as a CAN bus, which is a bus over which all equipment, electronic equipment, communicate. It's a serial communication protocol, CAN bus. In the military aerospace, you have a MIL bus, MIL 1553 bus. It's a communication two-wire bus over which various communication equipment communicate and talk to each other. They even command each other. Why hasn't anybody talked about a communication bus for the household? You can actually. So if you can apply what you studied or what you learned in the automobile sector, you can apply, you can invent and implement a communication bus. So you can get rid of a lot of wiring in your house. Instead of the thick wires, you can have signaling wires, and the power cable will only go to an appliance which needs to have that raw power. So once you do that, your communication and inter-room communication, inter-product communication, inter-equipment, inter-house to house and house to factory, house to office, everything becomes simplified. I'm just thinking aloud. It's just to say that when you learn something, some technology, some protocol or whatever is used in one particular domain, you have to see, can this be used in the domain I'm working in? Can I get some benefit, or can I tweak it to get some benefit? And that's the thinking process that has to get set into your minds when you want to be innovative. And then if you condition your mind into this kind of a thinking process, then you will innovate on a day-to-day basis. That's the core theme of my talk here. So when you are taking all this into account, what I'm saying is that it stimulates a holistic approach. When you look at only one domain or one discipline, you will only think within the boundaries of that discipline. When you start thinking beyond the boundaries of this discipline, then your whole thought process opens out saying, I know of this method of achieving this in that domain, why not I apply the same thing into this domain? And that's very, very important, and that's where you get a lot of benefit, because you will achieve whatever I listed there: efficiency, less power, and less heat, less wastage, less cost. So many things will automatically turn up. Wherever it is feasible, you implement it and you get the benefits. Next, please. I talked about the environment. So what triggers innovation? I've already talked about it. You know how you are brought up right from the home environment. Environment, I have put it right at the top. The environment in which you are brought up, the environment in which you live, you study in your college, and then when you go out to work, the environment. If it's conducive for innovation, then innovation automatically happens, right? So you have to look for that opportunity, and if you find that opportunity, then your process gets extended beyond it. Just some time ago we were discussing about the lack of systems and the lack of supportive systems, shall I say, for innovation in this country, because we are all, the entire systems are set into grooves, almost as if they are plastered in concrete, and nobody wants to change the system. We have to change that system to make it conducive for innovation. Then you will find more and more innovation coming up and blossoming into products or processes. Ecosystem, that's what I just now talked about. It's not enough if you just have an environment. Let's say within an organization, you have the environment for encouraging innovation. Somebody comes up with an idea, then somebody says, hey, that's a great idea, let's try it. Now, to carry forward, you need some infrastructure, maybe you need some financial support, some kind of a support from your peers and the bosses. If it's an organization or an education institution, it will be the professors. That's the ecosystem. But going beyond the boundaries of the office or organization where you're working, if you want to make it into a product, it goes beyond that. So the question of licensing, to make it feasible to manufacture a product, you have to have support systems, manufacturers, vendors, etc., etc. So that's what I'm referring to as the ecosystem. So the ecosystem is not there. The innovation will happen within the organization, but will not go beyond that. The ecosystem is extremely important when you want to, ultimately you want the people of the country to benefit, the users to benefit. Out of the box thinking. The organization, the environment should ensure, or it should support, it should encourage out of the box thinking. That's how innovation happens. If you look at everything the way it is, the way it has been done all these years, then innovation won't happen. You have to be able to ask a question to yourself. Can I change this and do it in a different way, which will be better, which will save some money, or which will be faster, which will be more efficient? Then it will happen automatically. You will definitely find an opportunity for innovation in every product that you see, every product that you use, or every process that you use. The last point is very, very important, because unless you do a periodic review, today everything becomes obsolete within 3 or 4 years, especially electronics. 3 years, a mobile phone, nobody wants to replace or repair a mobile phone after 3 years. They want to get a better phone because it's available. So from that point of view, unless you review the processes and products on a periodic basis, you will not be able to identify the applicability of a modern process that is available to that product. It may be a new IC that is available, which makes the job of a mobile phone better today than it was 2 years ago. So you need to take this review mechanism into your day-to-day life. Again, I'm saying, don't look at it from your career point of view, don't look at it from your work point of view. Make it a way of life. That's exactly what I'm trying to say. Whatever you do, whatever you handle on a day-to-day basis, minute-to-minute basis, try and see if you can make an innovative improvement into that, and it will happen. There is nothing that is what you call best or optimal, or that can't be improved. So there is an opportunity for improvement because of the way technology is changing, because of the way advanced materials are available every day, every year. So you need to review and say, okay, what I designed 2 years back, is it still applicable today, or should I change? Should I change the material? Should I change the component? Should I change the way it looks? Because aesthetics also changes with time. So these are all things that trigger innovation, and that's why I'm saying that if you want if we provide for these kind of thinking and these kind of environment, then innovation will automatically happen. The photographs I put at the bottom is my son. This was when he was just about 9 or 10 years old. You can see that he is working on a vise, and that happens to be my dining room in my house. And here he's got a blueprint. He is still in school, but he's studying a blueprint and building an aeroplane model for himself. That is what I'm saying is the environment that you all need to look for yourself and for your friends and for your children as you grow up. That triggers innovation. That triggers your method of thinking in a totally different way. Please.
How will you judge if you are innovating properly? You might be doing something totally irrelevant, like for a smartphone and having a curved screen. You can call that as innovation also. Like how do you judge yourself whether you are innovating properly or?
Proof of the pudding. So when you eat it, if it's good, it's
good for me, sir.
So you have to take the feedback from others. So evaluating a product, when you have come with an innovation, everybody gets an idea. Today the problem is many people are scared to even discuss their idea, thinking that people will laugh at me. So you've got to be bold enough to discuss it with your peers or seniors and say, I have this idea. And that's where it takes you to the environment and the ecosystem. If you're working in an organization and you have an idea like that, and you take it to a boss and he says, no, this won't work, forget it. We are quite happy with what we are making. We don't need to take a change. You don't have the ecosystem. That's lacking. And so even if you have a brilliant idea, it won't see the light of day. So the ecosystem, that's where it comes in very useful. And that's why I'm saying you have to look for that ecosystem before you get into an organization. Does it have an ecosystem? If you want to be an innovator, if you really have that ambition, then you must say, okay, I want to get into an organization where innovation is encouraged, and they have the environment, and they have the ecosystem, right? So I'm trying to say that just as my father created the environment for me, I created the environment for my son. And the fact of the pudding, again, proof of the pudding. He is an aerospace engineer now. He's done a PhD in aerospace and working on aerospace design in the US. Also an alumni of IIT, OI. But the fact is that he took to aerospace because I encouraged him. He got interested in it, so I encouraged him and I taught him about how to read plans, etc. He was able to read plans and build his. He actually got an aeroplane model in his hand. He was flying aeroplanes at the age of 10. That is what you need to look for and provide and encourage. The formation of the ecosystem, the formation of the environment, and the environment should encourage you not just as an electronics or a mechanical or a hydraulics design engineer, but overall, right? Because if you are a specialist, today all organizations have verticals: electronic designs, mechanical design, civil design, metallurgical design or chemical design, etc. Very little interaction happens between the verticals. Interaction happens at a higher level, where exchange of engineering knowledge doesn't happen. So I'm saying that that interaction should happen at a much lower level, where you exchange information and knowledge and apply what you think is applicable from, let's say, metallurgy into a chemical engineering, or mechanical engineering to electronics to. That appreciation is absolutely required, because a product is designed not just as an electronic product today. It has a certain amount of mechanical component. It has a certain amount of even environmental engineering, because today e-waste is bad. So how do you reduce e-waste in your design of a product? All these questions need to be addressed. All this needs to be thought about, and then you arrive at the optimal design as of that day for that particular application, for that product. Unless you do this, your design is not going to be the best. Next, please. Now I'm going to quickly highlight some of the things that I have developed. I don't want any of you to think that I'm just trying to boast, but these are all very, very simple day-to-day applications born out of need, and that's why I've tried to identify this and how I tackle this. Now this is what is called a multi-layer coil tester. Now I started my industry by making wound coils which are used in energy meters of BHEL. Way back in 1979, 1980. There was no method of testing a coil. A coil has something like, it's about an inch diameter, has something like 10,000 turns. And when you wind enamel wire, sometimes because of defects in the winding machine or in the process, the enamel wears off, and therefore you have shorts between adjacent turns. And when you have short, it acts like a shorted secondary in a transformer, and therefore the coil does not work efficiently. So when we used to deliver these coils, this was a contract from BHEL. We were about 10 of us vendors, and we had no method of testing it. We would give it to BHEL. BHEL would fit it into their energy meters, and then where the energy meter did not function properly, they would remove the coil and say, these are your coils, they have failed, they're not properly wound. So I came up with this tester. I designed the circuit, developed this tester for designing, for testing the multi-layer coils to check its magnetic properties and thereby identify defects. It worked magnificently, and I was the only one out of 10 people meeting their rejection limit of 2%. That is, out of 100 coils, only 2 should fail. If it was more than 2, the whole batch would be rejected. So out of 10 people, I was the only one who was meeting that rejection limit. So again, it's not too much of an engineering, too much of a innovation, I would say, but the fact that an innovative test equipment has been triggered because of need, and again because of the exposure that I had to electrical engineering and little bit of electronics. Next please. This of course are the musical instruments which is my bread and butter today. I went into electronic musical instruments because from a young age I have been a musician. The first slide showed me as a playing a flute as a Carnatic instrumental artist. I've been performing on the flute over the radio and TV ever since 1968, and it was only about 8 or 9 years ago that I gave up, but I've performed on the national level. So the exposure to music itself triggered these products. These were born out of necessity for myself. I didn't want to develop it as an industry or as a commercial product. Whenever I wanted to sit and practice in music, Indian music, you have what is known as a shruti. You need a pitch reference. So that's the tambura or a harmonium shruti pattige we used to call, reed based, bellows operated. So whenever I played the flute at home for my practice, either my mother or somebody had to sit and operate the tambura or the harmonium shruti box. So I said, as an electronic engineer, I should be able to develop, because after all it's an oscillator and an amplifier. So I said it should be possible. I worked on it and created the first ever shruti box, which gave the sound of a harmonium. Then when I started showing it to some people, they said it's very nice and they would also like to use it. Then they would also say, why don't you make a tambura? That is the tanpura in Hindustani music. North India it's called tanpura. In Carnatic music it's called tambura. 4 strings which are tuned specifically to notes of your pitch, and these are plucked mechanically by an artist. So I said, if I have to make a tambura, then I have to develop an electronic tambura. So we came up with the first electronic tambura. These are actually true inventions. Electronic tambura, electronic shruti box. This is the tambura in its present shape. It's hardly this size. Compact. It can be set to either a lady's pitch or a gent's pitch or any pitch for an instrumental. This is an electronic tabla. Now again, this is very interesting because when I made the tambura, shruti box, etc., I gave to all renowned musicians like Balamurali Krishna. You name it, name the artist, they've got a product, and I used to interact with them very closely. But the tabla, because I was born and brought up in Delhi, my mother used to perform on the North Indian music, even on the radio as well as Carnatic music. And I was aware that a tabla artist used to come home every time my mother wanted to practice. So I was aware of the fact that there was a handicap in Hindustani music. They needed to hear the sound of the tabla because that is a reference to the tal cycle. In Carnatic music, you would have seen people marking the tala like this, right? Because this has got each wave of the hand, each beat has got certain meaning. It's a count. In tabla, that count is not on the hand, it's on the stroke of the tabla. So by hearing the stroke of the tabla, you know whether it's a count of 3 or 4 or 6 or 12, etc. So without the tabla sound being there, the North Indian musicians were not able to practice music at home. They had to get a tabla artist even for their practice, and they had to dole out money naturally for that. And those fellows would not come every day. They would come hardly for about an hour once in 2 or 3 days or maybe a week. So I came up with this invention. This is the electronic tabla. Of course, it's in its present form. It's again a small compact instrument which can play about 100 thekas, but the first one I made way back in 1987 had just about 12 basic thekas, which everybody needed it. So this is a tabla that plays by itself. It's a sample tone instrument. The samples of various tabla strokes are stored, and it outputs the strokes depending on the tempo, the shruti, etc. that you set it to, and the theka, different tals. You select, it plays as if a live person is playing. It overcomes the handicap of practice for North Indian musicians, and right from great people like Pandit Ravi Shankar, Bhimsen Joshi, Vilayat Khan, and other Amjad Ali Khan, everybody has been using this ever since it was developed. Veena, this is a improvised, I would call this an engineered. There's nothing different. You still have a vibrating string, tuning, etc., but it's been engineered. A regular traditional veena is made by artisan using hand tools, etc. This is fabricated using machines. The traditional veena cannot be dismantled. It's a single piece. Here you can remove this, and carry this in a hat rack of an aircraft or in the dicky of a car, which you can never hope to do with a traditional instrument. So again, you relate to that slide where I said innovation happens because you want certain improvements in performance, ease of use, ease of manufacture, lowering cost. All that is achieved in this. The cost of ownership of any of these products is nothing when you are compared to the older system when you had to pay repeatedly for a daily practice. Here there is nothing. You invest 3,000-4,000 and it serves you for 20 years minimum. Next please. Okay, this is again a revolutionary product. I called it a thalometer, again an invention. As I practiced, my mother had to put the thala for me because that's the South Indian method of performing music. I said I don't want my mother to sit and waste her time, so I said I must make a gadget out of it. So I developed what is called a thalometer. This has got a row of LEDs here and controls here. The row of LEDs constitute your counting mechanism. One light for each of the fingers the way we count it, and then one red light and a green light to denote these. So you set it to the particular thala, set it to a particular tempo, it keeps on operating and endlessly, and so that's your reference. So I don't need my mother or wife to sit and put the thala for me. We can't, as an instrumentalist, our hands are occupied, so we can't put the thala. Vocalists would be able to do it. So like they say, necessity is the mother of invention. But the larger issue here is that this product is fully designed at Radha. Not only the electronic design circuit, you design the PCB, you design the user interface, you design the cabinets. These are plastic molded cabinets, but the design has got to be aesthetic. It has got to be it has got to consider ease of manufacture, ease of repair, ease of maintenance, all this. So you get that exposure only if you have that multidisciplinary exposure. This again is a revolutionary. This is the Melamala I referred to, Melakarta ragas, 72 ragas, major ragas of Carnatic music. You have 12 radials like a clock, and along each radial you have 6 ragas of each chakra, and you press any button, it plays the arohana or avrohana of the raga. This is custom designed, and we manufactured only one of this for somebody who was interested in it, and it gives the display of what note is being played, whether it is a Kaisika Nishada, Kakali Nishada, Shuddha Daivata, etc., etc. Next please. Security products. Okay, this is a flasher way back in 1979, electronic flasher for two-wheelers, and I wanted to sell it to two-wheeler manufacturers, Bajaj, and so they said, who needs a flasher for a two-wheeler? Get lost. Ahead of time, because subsequently when the foreign bikes came, every bike had flashers and every Indian manufacturer also wanted it. So this was 10 years ahead of its time. Nobody wanted it, so the product died. Secura is again a home lighting system that we developed, is to enable lights in your house to come on and come off as at dusk, to ensure that it gives a lived-in look to the house. Automatically you can set it to a delay and it will go off at 10 or 11 depending on what your normal habit are. So even if you are not at home, I have put these lights, these systems on and gone out of station for 4 or 5 days. And the house used to be lit up and give an impression that somebody is here, somebody is moving, somebody is living there. So to keep off burglars at bay. Next please. I'm just trying to highlight simple things that can be innovatively devised and used in your day-to-day life. So this is another interesting thing. Now this is an adjustable shelf. My daughter happens to be a painter, so sometimes she's painting a painting which is as big as this wall. So now when she is working there, she needs all her painting materials at a height, whereas when she is working here, she needs all the painting materials at that height. So I thought I will create an adjustable shelf for her. Now this is the shelf on which she keeps materials that she wants, and it can be adjusted infinitely at any position. You just raise it, leave it there, it will stay there. There are no clips, no bolts, no clamps, nothing. Please play that video. It will just take 1 minute. This is again to give you the idea that you don't need to restrict your innovative capabilities to the field of your domain as a mechanical engineer or an electronic engineer or a civil engineer. If you have got an innovative mind, you can innovate in other disciplines, other areas also. Now see, now she is raising her painting. This is, of course, has been shot only as a demonstration. See how she will move this shelf to a higher level. Don't forget there is a bucket full of water here for her paint. Now it's just friction. All I have done is to have a small rubber pad into that adjustable thing. It's something that moves inside a C channel, and wherever you lift it and leave it, there is a small rubber pad that puts pressure on the back side of the channel, and that friction is enough to keep it in that position. It won't fall down. More weight you put, more friction, and therefore more rigidly it holds. Okay? Yeah, please, next slide. This is again a design of a float valve that I designed. I'm using it in my overhead tank. The idea I designed this was, the float valves that you get in the market today have a small orifice, so it fills in at a very low rate. I wanted it to fill up faster, so I took a normal PVC pipe, 25 mm dia, used standard available material, drilled all these holes. All this I have done at home. It's only one, it's not been productionized or anything, just to say that if you have an idea, if you want to do something unique, you can do it. So this is again a rubber ball toy which I bought from the market, used it as a valve. So it moves up. As this float moves up, only towards the end, initially the entire flow comes through the pipe. To last 3 or 4 inches of the tank, it quickly closes and closes the main supply of water. So it results in my tank filling up much faster than it would with your normal conventional float valve, because of the fact that you have a 25 mm dia, so it allows a higher flow. Next please. This is a very, very interesting plastic sealer. I found this in an exhibition in Korea, South Korea. It looks like a stapler. It's about the size of a stapler, slightly larger than a stapler, but it has 2 batteries, AA battery cells inside, just as nichrome wire here. You put a plastic bag or something between these two on top of this, press it. When you press it, there's a contact made in there, and the nichrome wire heats. So because of the heat, it fuses the plastic. As you slide it, it welds the whole bag. Extremely innovative, I thought, because I don't know if any of you have seen anything like this. I've been using it for the last 4 or 5 years in the kitchen. My wife uses it extensively when you want to open something. Partly you want to use the bag and then you want to seal it. She uses to seal it. You understood what I said? It's a sealer, plastic sealer, but in the form of a stapler. Rechargeable hand torch. This is a torch which has a magnet here and a coil, and as you shake it, the coil goes over the magnet, and therefore there's an induction of voltage, pretty high voltage, which charges a battery inside. There is no battery need to be changed. All you need is every 5-6 days, shake it 20 times, 30 times, and it gets charged, and you have a brightly lit LED torch. Beautiful. I haven't done it, so don't give me any credit. Next. Yeah, this is it shows a room divider in my house. One side is a dining area, the other is living area, and I have a TV here. So I said I want to watch TV on both sides. So I have a pillar on which the TV is mounted. One side I can rotate it simply like that and watch the TV either on this side or that side. Next please. I'll finish in the next 2 minutes. Yeah, these are some of the aerospace products. Again, there's a lot of innovation that happens here. We have just qualified this unit for airworthiness. It's going to fly in a Jaguar aircraft in the next 10 or 15 days. This goes into a Dornier aircraft. This goes into again a MiG or Jaguar. Both it flies. Test jig. A lot of innovation that goes on to make things that appear to be very complex but completely indigenous and designed and manufactured within the country. Next. I think I'm through. I'll be very happy to answer any questions that you have. Feel free to ask anything you want.
Sir, your goal that this multidisciplinary thing is very then why were our engineering courses so divided?
That you'll have to ask your faculty members.
It's a generalized thing. I hear this from many a times from scholars that you need to have multidisciplinary exposure. Then why the management decide like that?
I would think that the reason for doing this is they presume that there's so much to learn in your own discipline that they want to maximize the time available to teach you more in your discipline rather than other disciplines. So both have its pros and cons, but I think as you graduate, even in your college life itself, you can look a little bit this side and that side into other areas, and that will benefit you. That's the point I'm trying to make.
Let's thank Raj again for his
Thank you.
token of appreciation. Commander Menon is your back.
Yes, yes.
Any always nice to receive it from our.
At least I'll have a photo with you, because I don't have a photo with the two of us together. Thank you. Since Menon is here, we were both together doing our masters. I was on deputation from HAL, he was on deputation from the Indian Navy, and we both stayed in Taramani House, and the exposure to multiple disciplines, etc., that I talked about, he also has it in it, because he took me into his submarine, the naval submarine, and showed me around. It was an education by itself. You know, you need those kind of opportunities. So I'm happy that he's here.
God.
Thank you for your attention and for being here.
This is my product.